Hello everyone. Today we will going to see some practice questions from the chapter Physical and Chemical Equilibrium, and this is our part 3. So let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Index slide. So we will going to see some practice questions from question number 17 to question number 24. Let's start with the question number 17. An aqueous solution contains 0.1 molar H2S and 0.2 molar HCl. If the equilibrium constant for the formation of HS minus from H2S is 1 into 10 to the power minus 7 and that of S2 minus from HS minus ions is 1.2 into 10 to the power minus 13, then the concentration of S2 minus ions in aqueous solution is. Options are 5 into 10 to the power minus 8, 3 into 10 to the power minus 20, 6 into 10 to the power minus 21, 5 into 10 to the power minus 19. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. So it has a correct option as B option. So we have given that H2S concentration is 0.1 molar and HCl concentration is 0.2 molar. So we can say that H positive is 0.20 molar because HCl is 0.20. So all the H positive will come from HCl. So H positive will also be 0.20 molar. Now you can see here is a reaction of H2S dissociating into H positive and HS negative ions. And for this, the ionization constant will be 1 into 10 to the power minus 7. And HS negative is dissociating into H positive and S2 negative. And for this, K2 is equals to 1.2 into 10 to the power minus 13. It means that for this reaction, H2S dissociating into 2H positive plus S2 negative, the K, the equilibrium constant for this reaction will be K1 multiplied by K2. That means if we add these two reactions, right? Because if we add two reactions, so their constant or their equilibrium constant will get multiplied. So if we add these two reactions, we get this third reaction here. So the K for this third reaction will be the multiple of these two reactions. That is K1 into K2. So which is 10 to the power minus 7 multiplied by 10 to the power minus 13 into 1.2, and it is coming out as 1.2 into 10 to the power minus 20. Right? Now S2 negative concentration will be equals to K into H2S divided by H positive to the whole square. So we write this equation by looking at the final equation we have. So final equation we have is this. H2 is giving you 2H positive and S2 negative, right? So K for this reaction is, we have calculated here that it is 1.2 into 10 to the power minus 20. And also you can write K equals to the product of concentration of products divided by the product of concentration of reactants, right? So on writing that equation and on interchanging that equation to get the concentration of S2 negative ion, we have S2 negative ion concentration is equals to K multiplied by H2S divided by H positive to the whole square. And on putting the values given in the question, K is 1.2 into 10 to the power minus 20, H2S is 0.1 molar, and H positive is 0.2 molar to the power whole 2. On solving, we have the concentration of S2 negative ion as 3 into 10 to the power minus 20 molar, right? So our option B is the correct answer for this question. Okay. Yeah. So Let's move to the next question, question number 18. We have given three equations here, N2 plus 3H2 giving 2NH3. The rate constant is K1. N2 plus O2 giving us 2NO. Rate constant is K2. H2 plus half of O2 giving us H2O. Rate constant is K3. The equation for the equilibrium constant of the reaction, this 2NH3 plus 5 by 2O2 will give you 2NO plus 3H2. K4 in terms of K1, K2 and K3. So we have to find out the equilibrium constant for this reaction, which is K4, in terms of K1, K2 and K3, which are equilibrium constant for these three reactions given in the question here. Options are K1, K2 divided by K3, K1, K3 square divided by K2, K1, K2, K3, K2, K3 cube divided by K1. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so we have our answer as option D. So let's see how. In the required equation, this is our required equation, right? Because we have to get the equilibrium constant for this reaction. So in the required equation, NH3 is on the left hand side. You can see that NH3 is on the left hand side. So we have to interconvert these three reactions somehow. So to get this final reaction. So as you can see, NH3 is on the left hand side. So we invert this first equation here. So NH3 will come on left hand side. So it will become 2NH3 will give you N2 plus 3H2. And the K1, right, will become in the inverse. Like K5 will become equals to 1 upon K1. Because this is a new, let's suppose this is a new equation forming by reversing this first equation. So this new equation has rate constant K5 and which will be equal to the 1 upon K1, which is the equilibrium constant for this first reaction, right? So let's suppose this is fourth reaction. First, second, third, and this is fourth reaction. Now what we will do, there are 3 moles of H2. So we multiply equation 3 by 3. So as if you see in this final reaction, we have 3 moles of H2 on the right hand side. So we have H2O in this third equation. So what we do? It is H2 is on the right hand side, it's fine. But its 3 molecules should be present, right? So we multiply this third equation by 3. So what will happen? We get this equation. So let's suppose this is a new equation whose equilibrium constant is K6. So it will be equal to K3 whole cube in term of K3. And let's suppose this is a fifth equation. Now, because when a reaction is multiplied by n, k becomes k to the power n, right? We know this concept. That's why this k6 will become equal to k3 to the power 3 because we multiply by 3 the third equation, right? Now, n2 plus O2 will give you 2NO. It has a rate equilibrium constant k2 we have given. Now, on adding the equation fourth, equation 2 and fifth. So, fifth is this, fourth we just find out, and second is this. So, on adding these three equations, we get this equation, which we needed finally. That is 2NH3 plus 5 by 2O2 will give you 2NO plus 3H2. Now, it has a K4 equilibrium constant, and as we have added fourth, second, and fifth, we just multiplied these three equations equilibrium constant by each of them. So it will be K2 into K5 into K6. So K4 will become equal to K2 into K5 into K6. And on putting the value of K5 and K6, K5 we have 1 upon K1 and K6 we have K3 whole cube. So K4 will become K2, K3 whole cube divided by K. So this is the final relation between K4 and K1, K2 and K3. Right? And hence our option D is the correct answer. Okay, let's move to question number 19. The equilibrium constant Kc for the reaction N2 plus O2 will give you 2NO at temperature T is 4 into 10 to the power minus 4. The value of Kc for the reaction this. So we have a equilibrium constant for this reaction at the temperature this. temperature is also given, and we have to find out the value of Kc for this reaction at same temperature. Options are 0.02, 2.5 into 10 to the power 2, 4 into 10 to the power minus 4, or 50. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so you can see that the correct answer is option D. So we have this equation given in the question, N2 plus O2 will give you 2NO, and the Kc or the rate constant is given, which is Kc equals to NO to the whole square, because 2 is the stoichiometric coefficient of product, NO, divided by the reactants, N2 and O. And Kc is equals to 4 into 10 to the power minus 4. And so on solving this equation, we have Kc value, and we don't know NO and N2 and O2 concentration, right? Now, if we invert this reaction, if we invert this given reaction, it will become 2NO, will give you N2 plus O2. And let's suppose its Kc will become Kc prime, so which will be equal to 1 upon Kc, because we revert this reaction here, right? So 1 upon Kc, and on reverting, this also become opposite. So product will be N2 and O2. So N2 O2 divided by reactant NO to the power 2. And 1 upon Kc means 1 upon 4 into 10 to the power minus 4, which is 10 to the power 4 upon 4. Now, what we will do, we divide by 2 this equation, right? So what will happen? 2 divided by 2 will become 1. 1 divided by 2 will become half, and 1 divided by 2 will become half. And this is the final reaction for which we have asked the value of Kc. So this is our final reaction. We have done it. Now Kc for this is, suppose, Kc double prime, and it will be products divided by reactants concentration. Products are N2 to the power 1 by 2, because 1 by 2 are the stoichiometric coefficients. N to the power 1 by 2, O to the power 1 by 2 divided by NO. NO is reactant. So we can clearly see that Kc double prime is nothing but under root of Kc prime, right? This is Kc prime. So you can see, right? Because square will become 1, 1 will become half. So Kc double prime is under root of Kc prime, which is under root of 10 to the power 4 divided by 4, which is equals to 100 divided by 2, which is equals to 50. And hence we have Kc for our final equation asked in the question. For this equation, we have Kc equals to 50. Okay, hence option D is our correct answer. Okay, let's move to question number 20. For the following equilibrium, N2O4 going to 2NO2 in gaseous phase, NO2 is 50% of the total volume when equilibrium is set up. Hence, percent of dissociation of N2O4 is. So we have this equilibrium given in the gaseous phase, and we have given that NO2 is 50% of total volume when equilibrium is set up. When equilibrium set up, NO2 alone is 50% of the total volume, and we have to find out the percentage of dissociation of N2O4. Options are 50%, 25%, 66.66%, 33.33%. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. So this is the equation, equilibrium equation we have given. So initially, let's suppose this has 1 mole. As we can see also that 1 mole is giving 2 moles of NO2. So let's suppose this is 1 mole and this is 0 mole initially. Now the moles at equilibrium will be N2O4 will be 1 minus X, and 2NO2 will be 2X if X moles are utilizing. So total moles will become at equilibrium 1 minus X plus 2X. It will be 1 plus X. Therefore, percentage of NO2 by volume will be equal to 2x because we are finding the percentage of NO2. So NO2 at equilibrium is 2x. So 2x divided by 1 plus x total moles into 100. So the percentage is coming out as 50, or the part is coming out as 50 of NO2. And we can say that x is equals to 1 by 3, which is equals to 0.33, right? So this is given in the question that NO2 is 50% of total volume, right? When equilibrium is set up. So percent of NO2 by volume we have given as 50. And on calculating, we calculate it like by the moles of NO2 at equilibrium divided by total moles into 100 for percentage, and it is equals to 50. And on solving this, we have x value which is equals to 0.33. And hence the percent of dissociation of N2O4 will be 1 minus 0.33, which is 33.33%. Okay, 1 minus or 100 minus. This is the final answer, and thus our option D is the correct answer for this question. Okay, move on to question number 21. At certain temperature and a total pressure of 10 to the power 5 Pascal, iodine vapors contain 40% by volume of iodine atoms. Kp for the equilibrium I2 to 2I will be. So we have given that the total pressure is 10 to the power 5 Pascal, at which the iodine vapors containing 40% by volume of iodine atoms. Iodine vapors who have 40% of volume of iodine atoms. So this is the conversion. I2 is giving 2I atoms, right? I2 molecule is converting to 2I atoms, and we have to find out the Kp for this equilibrium. Options are 0.67, 1.5, 2.67 into 10 to the power 4, or 9 into 10 to the power 4. And hence, we have to find out the correct answer. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. We have this conversion from I2 molecule to I atoms. Partial pressure of iodine atoms is P1, let's suppose. So it will be equal to 40 divided by 100 because the 40% by volume of iodine atoms is present. So 40 divided by total volume, which is 100, into 10 to the power 5 because the total pressure is 10 to the power 5. So this is basically the fraction of, fractional ratio multiplied by the total pressure is equals to the partial pressure. We use this concept, and we have partial pressure of iodine atoms is equals to 0.40 multiplied by 10 to the power 5 Pascal. Now, partial pressure of I2, P of I2. So we have find out here the partial pressure of iodine atoms. Now partial pressure of I2 molecule will be 60 divided by 100 because iodine vapors have 40% by volume of iodine atoms. So remaining are molecules of iodine. So 100 minus 40 will be 60. 60 divided by total, that is 100 multiplied by 10 to the power 5, which is total pressure, and it is coming out as 0.6 into 10 to the power 5 Pascal. Therefore, the Kp for this conversion we have is P of I whole square divided by P of I2, right? Because the rate constant for this equilibrium will be product divided by reactant concentration, and product have 2 as stoichiometric coefficient, so it will become the power of Pi divided by P of I2. And on putting the values, we have Kp is equals to 2.67 into 10 to the power 4. Thus, our C option is the correct one. Okay, let's move to question number 22. For the reaction N2O4 going to 2NO2, the degree of dissociation at equilibrium is 0.2 at 1 atmosphere pressure. The equilibrium constant Kp will. So we have degree of dissociation at equilibrium 0.2, and we have to find out the Kp for this conversion. Options are 1 by 2, 1 by 4, 1 by 6, or 1 by 8. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so we have answer is C option. And as you know that this is the reaction or this is the conversion given in the question. Initially, N2O4 has 1 mole and NO2 has 0 moles initially. Now at equilibrium, the N2O4 dissociates by alpha, so 1 minus alpha, and total moles here at NO2 will be 2 alpha. The moles of N2O4 at equilibrium is 1 minus alpha, and alpha is given as 0.2. So 1 minus 0.2 is 0.8 moles. Similarly, moles of NO2 at equilibrium will be 2 alpha, 2 into 0.2, which is 0.4 moles. Now, total moles at equilibrium is the moles of N2O4 plus moles of NO2, 0.8 plus 0.4. It is 1.2 moles. We have to find out the equilibrium constant Kp. Kp is in terms of pressure. So we have to find out the pressure of N2O4 and pressure of NO2. So pressure of N2O4 will be its moles 0.8 divided by total moles 1.2 into 1 atmosphere, which is total pressure. It is coming out as 2 by 3 atmosphere. Similarly, partial pressure of NO2 is moles of NO2, which is 0.4 divided by total moles 1.2 into total pressure, that is 1 atmosphere, and it is coming out as 1 by 3 atmosphere. Here we are using the formula partial pressure is equals to mole fraction into total pressure. Okay, so Kp we know for the reaction is product concentration divided by reactant concentration. The product we have is NO2 and 2 is stoichiometric coefficient, so it will come into the power. So and for NO2 we have partial pressure as 1 by 3, so 1 by 3 to the power 2 divided by 2 by 3, and it is coming out as 1 by 6, and hence option C is the correct answer. Okay, so let's move to our next question number 23rd. At 30 degrees Celsius, Kp for the dissociation reaction this is 2.9 into 10 to the power minus 2 atmosphere. If the total pressure is 1 atmosphere, the degree of dissociation of SO2 Cl2. We have to find out alpha now, and we have given that assume 1 minus alpha square is equals to 1. We have this reaction also, dissociation reaction. Options are 87%, 13%, 17%, or 29%. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option C. This is the reaction given. Initially, 1 mole of SO2Cl2 is present and 0 moles of SO2 and Cl2 are present. Now at equilibrium, it dissociates by alpha, so 1 minus alpha and SO2Cl2 are alpha and alpha. Total moles is 1 minus alpha plus alpha plus alpha. That means 1 plus alpha. Now pressure of SO2Cl2 is equals to 1 minus alpha, that is the moles of SO2Cl2 divided by total moles 1 plus alpha. And pressure of SO2 is alpha, that is moles of SO2 divided by total moles, which is 1 plus alpha into total pressure, but total pressure is 1 atmosphere, so it will become this only. Now what we will do, P for Cl2 we have alpha divided by total moles 1 plus alpha, and now we will calculate the Kp, which is equals to product upon reactants, and as the product is Cl2 and SO2, so alpha divided by 1 plus alpha to the power 2, because pressure of Cl2 and pressure of SO2 are same, divided by the pressure of SO2Cl2, which is 1 minus alpha upon 1 plus alpha. On interchanging the terms and on calculating, we have Kp is equals to alpha square upon 1 minus alpha square. And we have given in the question that 1 minus alpha square is 1, assume. So this denominator will become 1, so Kp will become equal to alpha square. Now alpha will become equal to under root Kp, and we have Kp value. So under root 2.9 into 10 to the power minus 2. And on solving this, we have alpha is equal to 0.17. Therefore, we can say that on multiplying by it by 100, we have 17%. So degree of dissociation is 17% in percentage, right? And thus we have our correct option as option number C. Okay. Let's move to next question, question number 24. The equilibrium constant Kp for the reaction PCl5 giving us PCl3 and Cl2 is 1.6 at 200 degrees Celsius. The pressure at which PCl5 will be 50% dissociated at 200 degrees Celsius is. So we have to find out the pressure now at which our PCl5 dissociate 50% at the same temperature at which Kp is given for this reaction. Options are 3.2 atmosphere, 4.8 atmosphere, 2.4 atmosphere, or 6.4 atmosphere. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so we have correct answer is option B. This is the reaction. Now, initially, PCl5 is 1 mole, PCl3 and Cl2 are 0 mole. At equilibrium, the PCl5 is 0.5, PCl3 is 0.5, and Cl2 is also 0.5. Because the pressure at which PCl5 will be 50% dissociated, that means 1 will get reduced to 50%, that is 0.5, right? So it will also 0.5, it will be also 0.5. So total moles will be 0.5 plus 0.5 plus 0.5, which is 1.5. And partial pressure for PCl5 is 0.5 divided by 1.5. P is the total pressure, let's suppose. Partial pressure for PCl3 is 0.5 divided by 1.5. Basically, moles of PCl3 divided by total moles into P, total pressure. And partial pressure of Cl2 is moles of Cl2 divided by total moles into total pressure. P is the total pressure, as I said. Now, what we will do, we find out the Kp on putting these partial pressures, like product in the numerator and the reactants in the denominator. So we have 0.5 divided upon 1.5 to the whole square divided by 0.5 upon 1.5 p. So as you can see, both are same. So 1 will cancel out and it will be 1 by 3 p. And you can say that Kp is equals to 1.6, which is given, right? So P will become equal to 4.8 atmosphere, because Kp is given in the question, right? So on equating Kp equals to 1 by 3 P on putting Kp equals to 1.6, we have 1.6 equals to 1 by 3 P, so P will become 3 into 1.6, which is 4.8. So P is 4.8 atmosphere, and hence we have our correct option as option number B. Okay, thank you.